Assalamu alaikum wa rahmatullahi wa barakatuh. This is the session number 9, Network Architecture. In this session, we will handle 3 topics: K protocols, user services and the network architecture, and authentication. We will start by the K protocols. It is useful to think of mobile network in terms of generations. As we know, they are upgraded from the second generation to the second and half to the third generation. Now, for the second generation, it is digital mobile networks. It depends on the GSM protocol, or the abbreviation for Global System for Mobile Communications, which support the SMS short messages, in addition to the voice callings. Also, the second generation depends on the TDMA protocol, the time division multiple access, where time is divided into slots and only one mobile terminal transmits during each slot. This exactly like what's happening now. During our lecture, only one can talk, but others may take the floor in turn. Each user is given a specific slot. No competition in mobile network, unlike CSMA, carrier single carrier sensing multiple access in Wi-Fi. For the second and half generation, it depends on the TDMA protocol, same as the second generation, but the new technology was added to this generation, which is the edge enhanced data rate for GSM evolution, in addition to the GPRS protocol, or the General Packet Radio Service, for the global system for the mobile communication. For the third generation, it is high-speed digital mobile network, including video telephony. It depends on those new technologies, UMTS protocol from the Universal Mobile Telecommunication System. The UMTS is an upgrade from the GSM via the GPRS or ETGE, or the enhanced data rates for the GSM evolution. Also, the third generation depends on the CDMA protocol, the code division multiple access, used for orthogonal codes to separate different transmissions, where each symbol of bit is transmitted as a larger number of bits using the user-specific code or the spreading technique, where all users use the same frequency band together, and the bandwidth occupied by the signal is much larger than the information transmission rate. This was a fast review for the evolution from the second generation to second and half to the third generation of the mobile networks. Actually, each of the 3 generations has its own protocols, where there are some similarities and there are some differences. Here we will not concern what the similarities or the differences. They were presented in details in the past lecture for the evolution from second generation to the third generation. Also, you can do your search from the internet to get more details for them. The second generation and the second and half generation have different protocol stacks, which used for the control plane and the user plane. But what is the protocol stack? Protocol stack simply is a set of network protocol layers that work together. The stack resides in each network element, and the layered approach lets different protocols be swapped in and swapped out to accommodate different network architectures. It is important to know what is the difference between the control plane and the user plane. control plane, as a definition, is the view of the network which describes the signaling protocols that referred to as the control plane. The control plane, anything that not use the data or not related to the data. The control plane deals with settings of the connection, authentication, taking care of mobility management, that the control plane. But the user plane, as a definition, is the view of the network which describes the protocols for the transmission of the user traffic, that is referred to as the user plane, or by other words, the user plane for the data and deals with the internet data you want to transmit. In this lecture, we will shine the light on the layered protocol approach of the third generation network. Let us at first explain the diagram. We have three divisions for the architectural mobile network, which they are: from the left side we have the user equipment division. User equipment, UE. It consists of the mobile devices which used by subscribers. What is the user equipment, UE? The user equipment is another name for mobile devices such as mobile phones, PDAs, and data cards for both built-in or external for the laptops of computer. The user equipments communicate with the radio base stations over the radio interfaces using a frequency band exclusively allocated to a particular operator. For the middle division, we have the radio access network, which is responsible to give users access to the core network, and it consists of base stations and their associated wireless technologies, in addition to the base station control nodes, which they are the elements that immediately control the base stations. For the most right side, we have the core network division. It's largely a fixed communication network, and among other functions such as it authenticates users, routes calls, routes data, works out billing charge. Also, the core network employs many communication technologies, including wire, fiber, and sometimes fixed microwave links. Each division consists of a set of blocks. We call the set of those blocks as protocol stack. Those blocks, we can call them also data units, while they are provides data. Each protocol has two endpoints. For example, here we have phi from physical protocol. The start point is UE, the user equipment, and the other endpoint is node B. Other example here, the GPRS mobility management, GMM protocol. The first end is user equipment and the other end is SGSN. The SGSN, short for Service GPRS Support Node. It mediates access to network resources on behalf of mobile subscriber. As you can see, the phi layer acts as the radio interface between the UE and the ATM, asynchronous transfer mode block. And for the above layers, MAC, RLC, and RRC, all those layers, all of them terminate here in the RNC block, while the top layer, we have only protocol which is the GMM directly terminated on the SGSN. GMM messages are carried over the intermediate nodes, which they are node B and RNC, by lower level protocols, Radio Resource Controller, the RRC, and Radio Access Network Application Protocol, RANAP. RRC and RANAP transport the GMM messages but don't alter them in any way. So the intermediate nodes are invisible to the GMM protocol. Also, for the three protocols, RNAB and modified SS7 stack and ATM, all of them will forward the incoming signals to the corresponding same name protocols from the SGSN side. From this diagram, we can tell that each block can be thought of as communicating with the block of the same name at the other endpoint, using the services of the layers below. For example, the radio link control RLC blocks communicate using the services of the medium access network, the MAC, and the P layers. Blocks communicating in this way are said to be communicating on a peer-to-peer basis, and the two blocks are often referred to as peer entities. Other example here for the peer-to-peer communicating is MAC block and RRC block. Also, it should be noted here when a node converts from one protocol to another in each direction is called protocol interworking. And here is example of the protocol interworking. At the lowest level, the node B has blocks labeled V and ATM. So, node B responsible to convert in both directions between the V protocol and the ATM protocol. The ATM protocol is used to transport user traffic and signaling messages across the fixed part of the network from the node B to the SGSN node via the RNC node. Now we will handle the blocks which form the user equipment division and the radio access interface. The blocks labeled V refers to the physical layer as we told before, and its function to compresses a number of different physical channels. The physical layer is used for the following. Number 1, user traffic to handle what is related to user data, payload. Number 2, transport of signaling messages, means to enable the system to operate correctly. And number 3, to manage the radio link itself. Now for the MAC layer. MAC came from Media Access Control Layer. Its principal 4 functions are: the first is prioritization between data follow address to a single piece of user equipment and data follows address to different pieces of user equipment. The second function, that is multiplexing data units which are arriving from the upper layer onto the data units delivered to the physical layer. In addition to demultiplexing follows in the opposite direction. The multiplexing meaning is sending multiple signals or streams of information on a carrier at the same times in the form of a single complex signal and then recovering the separate signals at the receiving end. And for the demultiplexing, the opposite process. The third function is encryption. If this has not been carried out by the RLC layer, the encryption meaning is the process of encoding data and information into an unreadable form. The fourth function is traffic volume measurements. In mobile networks, traffic volume is a measure of the total work done by a resource or facility, normally over 20 hours, and is measured in units of ER-lang hours. It is defined as the product of the average traffic intensity and the time period of the study. Regarding to the RLC layer, this term came from radio link control. It's responsible for the following 3 functions. The first is segmentation. The segmentation of data units received from the next layer in sequence delivery of upper layer. which is the RRC layer, to make them into smaller data units to be forwarded to the MAC layer, and the transfer of user data in addition to the error correction. The segmentation as review is the process of taking the data and segmenting it so that you can use it more efficiently. The second function is reassembling data units received from the MAC layer into larger data units for forwarding them to the RRC layer. The third function is, if instructed to do so, the RLC layer will also routinely acknowledge packets and retransmit those which are reported by the receiver to the contain error. For RRC protocol, this term came from Radio Resource Controller. This protocol handles most of the major functions in radio access network, the RAN, including number 1, used for setting up of physical radio channels, reconfigure and re-establish radio peers. Number 2, reporting of radio measurements. The third function, transport of signaling messages between the mobile and the core network, also used to broadcast of information. The fourth function of the RRC is to instruct the RLC radio link controller layer whether or not to acknowledge packet. And here to remark it that the last three protocols which we explained them, MAC, the RLC, and the RRC, in addition to the physical layer protocol, all of them are classified together in the standard as the access stratum, which is the level provides the user equipment with the access to the core network. The RRC and RLC and the MAC protocols are used to manage the flow of data between the user equipments and the radio access network, and to control the allocation of radio channels. Node B does not participate in these protocols. Simply, it forwards the data to the user equipment. In the third generation standards, there are three types of channels. We will handle them in coming slides to explain where they are formed and their function. The three channels are the logical channels, transport channels, in addition to the physical channels. By this diagram, we can see where is the logical channel position. The logical channels for data follows between the RLC blocks, and the transport channel for the data between the MAC blocks. And if we go down, then the physical channel can be located between the phi blocks. It is for the data follows transmitted across the radio interface by the physical layer. This diagram shows the transport channel and the logical channel and the other network elements such as the phi, MAC, and the RLC and the RRC blocks, and show how they are logically mapped. Now, and by the highlighted parts from this diagram, we can show how the radio network controller, the RNC, can interact with the core network. This is done using the radio access network application protocol, which is the RANAP, which used to interact with the SGSN and also the MSC in the circuit switch domain. The RANAP make use of version of the standard signaling protocol used in circuit switch domain and signaling system number 7, the SS7. The version SS7 used in RANAP has been modified to run over the ATM protocol. Also at the very top of the stack, non-access stratum, NAS, which handles direct signaling between the mobile and the core networks without depending on the radio access network division. Now we will talk about the IP in the third generation networks. These days, more and more people enjoy the advantages of the portability and the flexibility of carrying their workstations in the form of laptops, notebooks, and PDA. To meet the needs of this new set of users, Existing computing environments based on fixed networks are being extended into the mobile domain. The third generation and wireless networks are seen as a major revenue stream by providing an additional level of flexibility and service to the user. For data access, services, and multimedia communication, it is seen as desirable to adapt traditional applications and services people are accustomed to use in the fixed network and extend them to make them available to the mobile user in a seamless manner. The most dominant service in mobility are the Internet services, which run on top of the IP protocol. Internet host mobility poses a problem at the network layer when a mobile node moves from one subnet to another. Routing tables have to be updated to route packets to the destination subnet instead of the original subnet. This procedure is highly inefficient and time-consuming. In particular, if a mobile host needs to retain a network address while changing the subnet, but if a mobile host changes its subnet address, all established transport layer connections are broken. For more clarity, imagine a computer downloading music while traveling by train. This user is using a laptop attached to a mobile handset. The mobile handset could be connected to the internet using data services provided by the GSM or CDMA networks. When the user registers for data services, the user initiates a data call. He will be assigned a unique IP address. Once connected, the user starts an FTP session, for example, to download the music file from the internet. This FTP session is based on transport layer connection that is dependent on the connection invariant. But as the train moves, the mobile station moves to another cell. The point of the attachment for data services and therefore the subnet may change. If the mobile station is now assigned a new IP address, all the transport layer connections will be breakdown. The FTP session will therefore be aborted. This is the problem. This is the mobility problem where mobile IP seeks to solve. Specifically, mobile IP defines a set of entities that enable routing of packets to the mobile node. What is the solution of mobility problem? What is the solution of this mobility problem? The solution should depend on using the location information the network holds in order to make the IP addressing system continue to work as the mobile moves from one subnet to another. The tunneling is the solution. The procedure of tunneling has the following steps. At first, the network puts each IP packet inside another IP packet. Then, the router packet can then be used to get the message to the router to which the mobile device is currently connected, at which point this router extracts the inner packet and sends it directly to the mobile device, provided in 3G and GPRS using the GPRS tunneling protocol, which is GTP. In the third generation packet core architecture, the SGSN serves GPRS support node, which is the gateway between the radio network and the core network handles both signaling traffic, for example, to keep track of user location, and the actual data packet exchange between the user and the internet. Since the user's location can change at any time, the packets are tunneled or encapsulated from the gateway to the internet, which is the gateway GPRS support node, the GGSN, via the SGSN over the radio network to the mobile device. The current architecture uses tunneled between the GGSN and the SGSN, and another one between the SGSN and the radio network controller, which is RNC. All data packets thus have to pass to the SGSN, which has to terminate one tunnel, extract the packet, and put it into another tunnel. This requires both time and processing power. The following diagram explains the inner and the outer levels, where the inner level, which also is called tunnel overhead, it represents the packet to be sent through the tunnel, and the outer level, which is called tunnel message, it consists of the headers added by the tunneling protocol. And the GTP uses the user datagram protocol, which is UDP, to send the tunneled packets, and also adds its own control header, which is used among other things to identify which tunnel is which. Session information in the packet switched side of the network is stored in a series of tables maintained by the SGSN and the GGSN, called the Packet Data Protocol (PDP) context. Each session is directed to a particular network physically, which connected to one GGSN, and this network is identified by a Uniform Resource Locator (URL), known as the access point name (APN). What is the APN? The APN and tunnel identifiers are held as part of the PDP context tables. Typical APNs points toward the internet via a network belonging to an internet service provider (ISP) or to a corporate data network. In addition to data transfers to single recipients, third generation also offers a multicast streaming and download service called MBMS, the Multimedia Broadcast and Multicast Service. This allows an IP multicast tree to be constructed within the mobile network, and eliminating the need to send multiple copies of the data across the network. The individual piece of user equipment subscribing to the relevant service from leaves on the multicast tree, so that each receives a copy of the data stream or the downloaded data. The streaming service is particularly suitable for supporting mobile TV. The download service can be used to distribute multimedia messages, for example, for advertising purposes. The majority of today's mobile TV services are delivered over existing 3G networks, since this is the fastest and easiest way to deploy mobile TV services. Existing 3G operators have enough capacity in 3G networks to scale up of a mass market of mobile TV services. Latest 3G technology, such as HSDPA, the high-speed data packet access, gives room for several steps of capacity increases. This allows for more users, while benefiting for both diversity and the quality of mobile TV services. The MBMS service introduces only small changes to the existing radio and core network protocols. Therefore, the MBMS can be introduced by a pure software upgrade in general, as long as underlying hardware provides sufficient processing, which is the case for all state-of-the-art network nodes. This reduces the implementation costs, both in terminal and in the network. It makes the cellular broadcast a relatively cheap technology if compared to non-cellular broadcast technologies, which require new receiver hardware in the terminal and significant investment into a new network infrastructure. Also, MPMS focus on the transport aspects of broadcast and multicast services. They provide transport bearers over which IP multicast packet, which can be delivered. They also provide protocols and codecs for the delivery of multimedia files and stream on top of the IP multicast bearers, which are provided by the MPMS. Now we will move to the second topic of our lecture, which is user services and the network architecture. Actually, most networks offer additional facilities associated with the voice service, known as supplementary services. There are many of these, but they include calling forward. The calling forwarding is a telephone service that automatically routes the user's incoming calls to another number. Other service, call waiting. Call waiting let you know when you have another incoming call while you are already speaking on your phone. Using the call hold service, you can then put the first call in hold, allowing you to answer the other incoming call or to make a second outgoing call. In addition to the other services such as notification of waiting incoming call and prevention of calls to or from a mobile handset. Other service, conference calls. Conference call is meeting conducted over the phone using audio between two or more people, and usually for the purposes of discussing a particular topic. There are many different terms used other than conference call, which mean the same thing, such as teleconference, voice conference, audio conference, or conferencing call. Other services such as voicemail. Voicemails are essentially digital records of outgoing and incoming voice messages that are managed either by an on-site or off-site. Also, the third generation networks allow video calls, and the user requests a video call using the normal phone number, and the network attempts to set it up with a called parity. As continue for the user services, here we have the data services. Here we have the internet access. The user is connected to the internet via an internet service provider, working in partnership with mobile network. Access to corporate networks through a virtual private network, VPN, typically utilize an IPsec tunnel in order to provide an additional layer of security. What is the IPsec? IPsec is a framework for a set of protocols for security at the network or packet processing layer of network communication. A big advantage of the IPsec is that security arrangements which can be handled without requiring change to the individual user equipment. The IPsec can be considered as a set of protocols for making IP communication more secure. Also here we have Multimedia Messaging Service, MMS. Multimedia Messaging Service allows still pictures, videos, and audio messages to be sent as much as longer text messages than SMS permits. What is the MMS? MMS, sometimes called Multimedia Messaging System. It is a communications technology developed by the 3GPP, the third generation partnership project, that allows users to exchange multimedia communications between capable mobile phones and other devices. MMS defines a way to send and receive almost instantaneously wireless messages that include images, that include audio and video clips in addition to the text. When the technology has been fully developed, it will support the transmission of streaming video. A common current application of MMS messaging is picture messaging, the use of camera phones to take photos for immediate delivery to mobile recipient. Other possibilities include animations and graphic presentations of stock quotes, sport news, and weather reports. Multimedia messaging is similar in one way to text messaging, in that it makes use of Multimedia Messaging Center (MMSC), which is used to store and forward messages. The MMSC, unlike the SMSC, it is fully IP-based device which can only be accessed through an IP network. When the user also we have streaming services which present audio-visual content to be the mobile device for buffering and immediate reply. Here we have two types of video streaming service. The first type, mobile TV, where the user can choose from a number of channels, but it is constrained by a program schedule. Mobile television is television watched on small handheld or mobile devices. It includes pay TV service delivered via mobile phone networks or received free to air via terrestrial television stations. Regular broadcast standards or special mobile TV transmission formats can be used. Additional features include downloading TV programs and podcasts from the internet and storing programming for later viewing. The second type, which is content on demand. Content is downloaded to the mobile device and can be replayed several times. The content provider may restrict the number of times the content can be played or specify an expiry date beyond which it is no longer available. From this figure, we can imagine how the data services are provided. The user is provided with a standard APN, which is a URL specific to the mobile network, and which needs to be selected as a setting on a mobile device, or on USIM, which is Universal Subscriber Identity Module card associated with the device. The APN points towards the GGSN interface connected to the Internet Service Provider ISP network, and the mobile device can use this to set up web browsing session. And from this figure, also we can imagine how the multimedia messaging, when the user wants to send message, the user equipment set up a session using an APN URL pointing to the MMSC. This is the third topic of our lecture, which is about the authentication. In the second generation, authentication is the process used to prove to the network that the mobile device is genuine and allowed to use the network. But in the third generation, the process is mutual. It also allows the mobiles to prove itself that the network is genuine. In both the second and the third generation, authentication is a functional of non-access stratum, where it takes place between the user equipment and the core network without the intervention of the radio access network RAN. By this diagram, we can explain the authentication procedure. Here we have three interfaces: the user equipment or the universal SIM card, the second interface SGSN, and the third one is the AUC. Now we will know how they are interact together. The first step, UE send a attach request toward the SGSN. Step 2, after receiving authentication request by the SGSN shall generate authentication vector, the AV, which is consisting of RAND, XRES, AUTN, CK, and IK. You can refer to the textbook to know what those terms means. Step number 3, the SGSN send the generated vector to the AUC. Step number 4, AUC replies authenticated vector including RAND, AUTN, XRES, CK, and IK. Step number 5, SGSN on receive this reply and keep XRES, CKI, and IK and send each of RAND and AUTN to the UE. Step number 6, the UE will do check, then receive the reply from the SGSN and send verify AUTN against RAND, then calculate the RES, CK, and IK. Step number 7, the UE indicates the authentication successfully and returning the RES to the SGSN. Step 8, SGSN compare RES with XRES. Then, if both are not equal, then controlling entity shall send attach rejected to the UE. Else, if both are equal, implies user is authenticated, then shall invoke next message of attach procedure.